Right. So today we are going to discuss about the failure or error, you can say. So we were talking about this transaction property already discussed, state of transaction, that all we have discussed, schedule, so that also we have discussed, serial schedule, non-serial, serializable, that all we have discussed, right? So today we are going to start from this one, failure. So that failure can be happen like many ways, right? So that classification of failure. So in our DBMS also, when you are doing some program, when your transaction is going on, that time some failure can occur, right? So say you are running one process or executing one process, that the process can be failed, or sometimes it can be success, or sometimes it can be fail, right? So that failure classification, there are different types of like failure can be there. So that are like transaction failure, system crash, disk failure. So transaction failure, that means your process when you are executing your transaction, in that if that process is failed because of some maybe error, logical error or syntax error, your transaction is not completed, not executed, that failure is called a transaction failure, right? So that transaction failure occurs when it fails to execute, or when it reaches a point from where it cannot go any further, like we cannot complete that execution, right? So say if a few transaction or process is hurt, then this is called transaction failure. Actually, the region of transaction failure can be like logical error, like in your coding, if you are having some like condition error or something logically, if there is any error is there, logical error is there, then it can occur, this type of failure, transaction failure may occur. And next, another one reason is syntax error. If in your code some syntax error is there, that also make your transaction fail, right? So the next failure is system crash. So sometimes our system goes to crash, right? So system failure can occur due to the power failure. Our system may crash, or our system can fail. The system failure, when it will occur, if it is the power is off, or any other hardware or software failure is there, then only it will occur, right? System failure will occur. So, for example, operating system error or power off or any kind of that system related failures comes under system crash or system failure. So, fail stop assumption in the system crash, non-volatile storage is assumed not to be corrupted. So that means our volatile memory and non-volatile memory, that storage. So here non-volatile storage is assumed to be not corrupted. That means, say, for example, so RAM, in the RAM, all the processes are going on. Okay, that is volatile. Right? RAM is volatile, right? Non-volatile is our secondary memories and all. So our secondary memory is generally not going to be crashed, or it say when our system is let's say, for example, going to be power off. So when you are running your transaction, that time say power is gone. So that time we are not going to lose our secondary storage data, right? In the secondary memory, whatever memories are data are there, we are not going to lose that. So corruption will not happen there, but corruption will happen in the volatile memory, that is in the RAM, where you are like doing your process and all. That is temporary, right? So system crash, the disk failure also happens. So it occurs when the hard disk drives or storage drives used to fail frequently. So sometimes our hard disk may be not working, right? So it was a common problem in the early days of technology. But actually, nowadays it is not that much because now we are getting lots of memory, right? Say, like hard disks we are having more than 1 TB now. In previously, it was like 100 GB, 160 GB, or 500 GB, like that only it was coming. But nowadays, it is more than like 1 TB, right? So failure actually now no chance to get fail, right, for the hard disk drive. So disk failure occurs due to the formation of bad sector like disk head crash or unreachability to the disk or any other failure which destroy all or part of the disk storage. Say in your disk, if some sectors or some uh, part is like damaged, then also this disk failure will happen, right? So now we are coming to recovery. See, failure, three types of failure we have got. That was transaction, system, and this. So now recovery. So if it is fail means we have to recover our previous data, right? So what is that recovery? How we will do that recovery? So one is log-based recovery. So what is log-based? Log. So this log is a sequence of records. So we are having our when we are running our transaction that operations or process in that this whatever record we are using there that we can store in one log file, right? So log of each transaction is maintained in some stable storage so that if any failure occurs then it can be recovered from there. So when we are starting one execution of the transaction, then what we'll do, whatever transaction is there, right? So we'll store that in one some storage place. We'll store that, right? So why we store that log in that log file? Why we'll store that? Because if sometimes if by chance any failure occurs, then we have to recover it, right? For that purpose, we used to stored our that records in the log file. So if any operation is performed on the database, then it will be recorded in the log. So we have this is log based recovery, right? Here that log we are maintaining, and what we are going to maintain in the log, that is our whatever operations we are doing, whatever operations we are performing on our database, that all record we are going to like store or we are going to just keep on the log or log file, right? So but the process of storing the logs should be done before the actual transaction is applied in the database. See, after commit that means this is permanently stored, right? That time we are not going to again recover it. Say this all log storing is valid till the commit. That means will permanently you store that records, right? Update that records. So say we are just taking one example. Say assume there is a transaction to modify city of a student, right? So for the following logs are written for this transaction. That means to modify the city of a student, what kind of log we can like record. So here you see first, see when the transaction is initiated, then it writes start log. So tn start it will right there. Then when the transaction modifies the city from Noida to say for example Bangalore, then another log is written to the file like this. So tn city transaction, that means city Noida to Bangalore. This is just maintaining the records in the transaction, whatever operation you are doing, that is maintaining in this log file, right? Then next, when the transaction is finished, then it writes another log to the to indicate the end of the transaction, like the end commit. That means here the commit means it is going to be finished, right? So there are two approaches to modify the database: deferred database modification and immediate database modification. Actually, in the deferred or after commit only in the deferred database modification. So once we have to do all our transaction, whatever operation is there, at the end, when we get the commit operation, right? Commit that operation we get, that time only it is going to be modified, I mean, update in our database. But immediate database, in that, like immediately, like when you are writing one operation, immediately whatever changes is there, it will reflect in the database also. It is going to be changed in the database also. So that is immediate database modification. And deferred database modification after completing on the transaction. Say before commit, say in the deferred database modification, what happens is, say when your transaction, your operation is failed in between, in middle of the operation, then your in the database, it is not going to be changed because it didn't reach to commit like a statement, right? If it get the commit statement, then only it will update in the actual database, right? In our database, it will, so it will reflect, right? But in the immediate, say you have written one statement, if there is any like update is there in on your database, and it will show immediately. But in this case, sometimes so many problem happens in immediate database modification. Generally, people don't use this deferred database modification, only use mainly in our computer science, right? So then recovery using log records. So we have created our log file, right? We have recorded our all changes or all operations in the log. So now by using that log record, we can recover our if our like transaction is failed, we can recover our data, right? So when the system is crashed, then the system consults the log to find which transaction need to be undone and which need to be redone. So each and every step we have recorded, right? Like whichever needed in our like log. So in that log we are having now, we have to, we can find out which are we have to undone and which are we have to redo. In previous whatever was exist, that all we have to redo, right? And others whatever newly we have done, that we have to do undo. So whatever we are going to be redone or which we are going to be undone, that will be decided. Or only commit, then what we will do? That, see here, if we see in our log record, say start, say for transaction T1 or TI, it is that it may be T1 or T2, whatever transaction one, start, and the transaction TI is commit. If we get both this or only this, then what we'll do? The transaction TI needs to be redone. So when we have to do the redone and undone, that how we'll decide. So in our log file, that means in our log records, what kind of records we are getting? Say if we are getting this start and commit together or only commit, then we'll do the redone, right? And if log contains record to start, but does not contain the record either T1 commit or TI abort. Say if we are not getting either commit or abort, then what we will have to do? We have to undo the transaction TI. Right. So in our log record, if we get that transaction either start and commit or only commit, then we have to do redo. And if we are getting only start, right, only start, we didn't get any commit or abort option, abort record on our log, then what do we have to do? Then that transaction need to be undone, right? So that you have to remember this. So now we are coming to checkpoint. So checkpoint, what is that? This one type of mechanism where all the previous logs are removed from the system and permanently stored in the storage disk. So checkpoint is like a bookmark, like our bookmark, how bookmark actually work. Say while we are executing the transaction, so like checkpoints are marked that time. Our checkpoints are marked actually, whatever you have checked, and the transaction is executed. Then using the steps of the transaction, and the log files will be created. So here another one, when it reaches to the checkpoint, then the transaction will be updated into the database. So until that point, the entire log file will be removed from the file. So if we get till the checkpoint, then whatever transaction is done, if it is updated, means that log file we have to remove, right? So now it is, see, in the database, if it is updated, now no need of that maybe log file. It is already done, committed. That means update is already done in your database. So the checkpoint we need, whether it is done or if we get the checkpoint, till that moment that log file will be available, right? So after getting the log file, entire log file can be removed actually. Then the log file is updated with the new step of transaction till next checkpoint and so on. Then, so the checkpoint is used to declare a point before which the DBMS was in the consistent state and all transactions are committed. This is then recovery using checkpoint. So a recovery system recovers the database from his failure. Like this, you can see here one example. So recovery system reads log files from end to start, from here to here. So it reads log files from T4 to T1, right? So recovery system maintains two lists, that is redo list and undo list, right? And the transaction is put into the redo list if the recovery system sees a log with start and commit or just commit. And the undo list if it is only start, there is no commit or abort statement, right? That time in that undo list it will put. In the redo list, what are the transaction will come, where we'll get the log file is like start or commit, or start and commit together, or only commit. But undo list, in the undo list we have to put wherever the only start is there. There is no commit or um, abort option is there, abort statement is there, right? So here the redo list and their previous list, all the transactions are removed and they're redone before saving their logs, right? Here one example is just take. So in our log files, a transaction T2 and transaction T3 is having like this start and commit. Then transaction T1 will have that commit this log file. So that's why the transaction is committed after the checkpoint is crossed. So hence it put T1, T2 and T3 transaction into redo list. Understood? Then next another one is undo list. Say transaction is put into undo state if the recovery system sees a log with the start, but no commit or abort log. So already that we have discussed, right? To put it in the undo list, in the log we have to get only start. There should not be any commit or abort log. But to put in the redo list, if we get like start and commit or only commit, then we'll put that in the redo list, right? The undo list, all the transactions are undone and their logs are removed. See, once you have undone all, then you can remove the log. No problem. So example that is transaction T4 will have start. So T4 will be put into undo list because it is not completed. This transaction is not yet completed and failed, right? Now we are coming to the deadlock. As we know, deadlock in the operating system also. Say, what is deadlock? When the processes are waiting for each other, right? They cannot execute their work, their operations. All are waiting for some resources. Without that resource, they cannot complete their that execution, right? So, like independently, they are like waiting for. So, one thing is it is loop. That loop is going each stop, right? Here, there is a condition to one example here. T1 transaction and T2 transaction. We have and T1 is student and T2 is and complete the T2 transaction. We need student it only. It is on. So see, you can see here. This is now like a loop, right? So this is T1 is waiting for T2, and T2 is waiting for T1 because T1 is holding student. But complete we need student and get both together. If T1 get this grade, then only it can finish its transaction. So now it is holding student and waiting for grade. So once it will get the grade, it can finish his work. But at same time, see T1 is waiting for student. It is holding only grade. So it is waiting for student. So this is also waiting for T1. So now both are waiting for each other. Now which is going to be left or leave the resource first? This is indefinitely. We don't know, right? Till we give some resource or something else. Till we stop this, it will be waiting, right? So this type of condition. This is deadlock. So waiting for each other, like T1 here, transaction 1 is waiting for transaction 2. If the transaction 2 is completed, then only he can release this resource, right? So great. So here, great is T1's resource. So regarding deadlock, I think you have got like good knowledge from the operating system class. So I think you know about this deadlock, what is deadlock and all. So here only basics we are going to discuss. In DBMS, deadlock in DBMS, how we are getting. So here with that table, we are having this resource. This is our student, and here it is grade. So both are waiting for each other, and this condition is here deadlock. So deadlock in DBMS. So when a database is stuck in a deadlock state, then it is better to avoid. This is deadlock avoidance. That we can like solve the deadlock problem in different way. It can be like deadlock avoidance, deadlock prevention, deadlock detection, right? So in deadlock avoidance, what we have to see if there is a like deadlock is there. If we can see that there will be any deadlock is there, then no need to enter there, right? You can avoid that. Understood? So now, for example, say if we can know that in our like Nerim, for example, in some place COVID is there already, right? If you know that COVID is already there in that place, so no need to, you can escape that, right? You can avoid that place so that you like you are not going to be positive in that, right? So just I'm giving one example like that. Say deadlock avoidance is like this. So if you can can get that some deadlock occurrence is there. If you can and you can detect that deadlock will be there, or deadlock may happen in that if you do that transaction, then you can avoid that, right? So this is waste of time and resources. Anyway, you should avoid this. Otherwise, if you go there, that is only simply like waste of time and resources. So better you can avoid it. So deadlock avoidance mechanism is to detect any deadlock situation in advance. So a method like wait for graph. This is one type of method that we will discuss. This wait for graph, this is used to detect the deadlock situation, right? So, but that wait for graph, this is suitable for, like, deadlock avoidance is suitable only for smaller database only. But if we are having like large database, then deadlock prevention method, deadlock prevention we can do. So now, how we can do the deadlock detection? Now we are coming to deadlock detection. So in the database, so when a transaction waits indefinitely to obtain a log, then the DBMS should detect whether the transaction is involved in the deadlock or not. See, in our database, say two processes are going on. Your transaction that is going on. That transaction is, we have, say you are going to conduct that transaction, then execute that transaction. So you have to check, you have to detect whether the transaction, whichever you are going to use, that one is already involved in the deadlock or not, right? So the log manager maintains a wait for graph to detect the deadlock cycle in the database. So how we'll find out that deadlock cycle or deadlock situation? For that, we can use that wait for graph. We can draw a graph. By seeing that graph, we can find out that deadlock is there or not. If there is any cycle is there, that means there is a deadlock. If there is no cycle in that graph, then there is no deadlock. Understood? So wait for graph, how we can draw that. So this is a suitable method for deadlock detection, that this wait for graph. So in this method, a graph is created based on the transaction and the log. So if the created graph has a cycle or closed loop, that means in our previous example, here you can see cycle is there, right? So this is waiting for this is waiting for this, is like a cycle. This closed path, right? That paths are not closed cycle, like closed work, you can say. So this is cycle. Here also cycle is there, so that deadlock is there, right? So if the cycle, like in the graph, the cycle is there or the closed loop is there, then there is a deadlock. Then we can find out, okay, by seeing that graph, we can see that deadlock is there. And the wait for graph is maintained by the system for every transaction, which is waiting for some data held by the others. So that is maintained by our system only. For every transaction, they will maintain. And that by seeing that graph, we can check, we can say that the transaction is in deadlock or not. The system keeps checking the graph if there is any cycle in the graph or not. So why the system actually frequently check is if there is any any graph is now cycle free, then they can use that, right? They can continue, that deadlock may be over. But if there is any cycle, then they have to check it, that it will create the deadlock. So system has to check frequently or time by time that whether the graph is cycle or not, having cycle or not. So here wait for graph. See here T1 in that our example. T1 is waiting for T2. That means T1 is also resource 1. So here resource 1 is our student and resource 2 is the grade. Right. So T1 is waiting for T2. If T2 relieve resource 1, then only T1 can finish his transaction, right? So both are waiting for each other. So this is having one cycle, right? So here that deadlock is there. So now we are coming to the next one, that is deadlock prevention. So we have to prevent deadlock now. So deadlock occurred, but we can prevent that. Right? Deadlock prevent method is suitable for large database. So we have discussed, right? Say that wait for graph, deadlock avoidance. So deadlock avoidance is suitable for like small database. But if you are having large database, then deadlock prevention is better than deadlock avoidance. So if the resources are allowed, allocated, resources are allocated in such a way that deadlock never occurs, then deadlock can be prevented. So if we are having some resources and we can allocate it like such a way that, so that there should not be any deadlock. The chance of deadlock occurrence is not there. Right? No chance of occurrence of deadlock. Then that is in that case we can say that the deadlock can be prevented. Right? So database management system analyzes the operations of the transaction, whether they can create a deadlock situation or not. If they do, then the database never allowed that transaction to be. So when they are they have to detect it, they can first check it if there is a situation like where they can prevent the database, deadlock, then they can execute it. If there is no chance to prevent, then it is better not to execute that transaction, right? So deadlock prevention, we can different some schemes are there, like wait die scheme or wounded. Another one is wounded wait scheme, like that. So wait die scheme, one transaction you can keep it wait, and one you can remove that condition actually. So here, say one example we'll take. So we are having wait and die scheme. Here in this scheme, what happens if the transaction request for a resource and which is already held with a conflicting lock by another transaction, then DBMS simply check the timestamp of both the transactions. Right. It allows the older transaction to wait until the resource is available for execution. So they just check their timestamp. Both the transaction, they will check the timestamp, whichever is older, they will keep that one for wait, and until that another one execution is the resource is available. So here that's all we are having one example. Two transactions Ti and Tj. There are timestamp for let a timestamp T we are having for transaction T, and if T2 holds a lock by some other transaction and T1 is requesting for resources held T2, then the following actions are performed by the two actions they used to do after checking this timestamp. So if the timestamp, say Ti's timestamp is less than Tj, or you can say T1 or 2, you can assume like that also. So if the Ti's timestamp is less than Tj's timestamp, then what will happen? That means if it is older, T1 is older and Tj has held some resources. Tj is having some resources. Then Ti is allowed to wait. Then this will wait. Ti will wait. And until the data item is available for execution. So it will wait, and this one they will finish. That means if the older transaction is waiting for a resource which is locked by the younger transaction, then the older transaction is allowed to wait for resource until it is available. So this one they will first finish till it will get the resource, right? So but T1 will be waiting another one is Deuri. And next option is like action what they can do. If that old like T1 is older and TJ, older than TJ, then what they will do? See here, but the resource is held by T1. So here TI is older and as well as it is holding the. Then what will happen? TJ is waiting for it. Then TJ is killed and restart later with the random delay but with the same timestamp. Right. So this is our second option. So you can kill TJ here, but here T1 is waiting. So on wait scheme, in this scheme, the older transaction request for a resource which is held by the younger transaction. Then older transaction is forces younger one to kill the transaction and release the. But after minutes delay, the younger transaction is again they can restart it, right? At the same time. But if the older transaction has held a resource which is requested by the younger transaction, then the younger transaction is asked to wait until older is released. So this is, yeah. Now we are coming to the concurrency control. So concurrency control is like waiting for, like the parallel is like execution is going, simultaneous execution is going, right? So if there is multiple transactions are there and they can be like they can be executed like simultaneously or parallelly, right? That is like concurrency. Concurrency is that. So now concurrency control. So it may affect the transaction results. It is highly important to maintain the order of the execution of those transactions. Okay, now problems of concurrency. See, when concurrently you are executing some transactions, that time there can be so many, there may be so many like problems. So what kind of problems may occur? So several problems when concurrent transactions are executing. Right. So there are three types of problem in concurrency controls we are having. Lost update. So updates, see, lost update, dirty read, and unrepeatable read. So this all we'll discuss in the next class. So today I'll finish here itself. So we are having another one class, it will be over. I'll start that one in the next class. So we can just take the attendance.